The fourth question, the number of unstable Lewis dot dash structures that can be drawn for the peroxynitric acid molecule. The formula is given HNO4. Okay, let's first draw the molecule. Now, in order to form the resonance structures, we have to look for places that we can put new pi bonds. Right, if you look at here, we can put a pi bond here, we can try a pi bond there, and in this position. So we can place 3 new pi bonds, and let's try to put the pi bonds without disturbing the net formal charge of the molecule and without disturbing the octets of the molecules, octet of the atoms as well. Okay, let's make a copy of this first. Let's try to put a pi bond in here. So what we have to do, we have to choose a particular lone pair to make a pi bond. Let's say we use this lone pair here. So if we use that pair of electrons to put a pi bond between this oxygen and oxygen, this oxygen exceeds its octet. Therefore we have to remove one lone pair from here. So we have to put that lone pair into another place of the molecule, and the best place to put that lone pair is the nitrogen, because the nitrogen has a pi bond, and we can remove that pi bond and put that electrons onto the oxygen. So I hope that you could understand that what I did was, these electrons were given to this oxygen, so this electron loses a pair of electron, so I gave that nitrogen the lone pair from here. Now the formal charges are changed, so we have to find the new formal charges. Now this oxygen has a plus, this has a plus, this has a minus. This nitrogen doesn't have a plus charge now. Alright, so the net formal charge is not changed, since it has more formal charges and oxygen have positive charges. This is kind of an unstable structure, so this is unstable. Let's try another structure here. Now the second place that we are looking here is this bond, so we have to look for a way to put a pi bond there, so we can get another resonance structure. So we have to use this electron pair. Let's use that. I'll remove that electron pair and put a pi bond here. Now the problem here is the nitrogen exceeds its octet, therefore I have to remove a pair of electrons from nitrogen, so the pi bond can be removed. Those 2 electrons can be given to the oxygen on the top. Right, so the formal charges are changed now. This can be put a minus charge here, we can put a plus charge there. Nitrogen plus stays. Alright, since this also has 4 formal charges, get here 1, 2, 3, 4 formal charges, it is also an unstable structure. Another reason for the instability is that oxygen has a positive charge, so this is also unstable. The next place that we can put a pi bond here is this one, between the nitrogen and the other oxygen. Okay, let's try to put the pi bond there. So we have to choose a lone pair to make a pi bond, so we can use this pair of electrons to make the pi bond. So I'll be erasing that pair of electrons and the negative charge will be gone. So I'll put the pi bond here. Now the nitrogen exceeds its octet, therefore I have to remove an electron pair belonging to the nitrogen, so I have to remove the pi bond here. So I have to put that electron pair onto the oxygen, otherwise its octet is incomplete. Now the formal charge become -1 of that oxygen. Nitrogen positive charge stays, and that's all. The net formal charge of the molecule is the same. It's the same as the first structure. Since it has lesser number of formal charges, it will be stable. So this is a stable structure. Since we had only 3 different places that we can put extra pi bonds, we can draw 3 resonance structures, and 2 of them are unstable, 1 of them is stable. So they are asking unstable structures, so it will be 2 unstable structures. The answer is 2 here.